Welcome to Abrar Electrical World YouTube channel. Today's topic is how to improve the transient stability of the power system. I have uploaded various lectures on power system stability, power swing blocking, load encroachment into distance relay, maloperation of the relays due to transient stability, the reason for instability, stable power system, power swing and unstable power swing, the projectile of the load line and the Z measurement line. And also I have in classroom setting interactive lecture, I have uploaded the characteristics blocking of the power swing by concentric characteristics, by blinders and by continuous measurement of the impedance, etc. I have done all in classroom settings where I have done interactively each and every lecture. I have also conducted for a long time power system studies of all kind for a period of 40 years in USA, in Pakistan, and with WAPDA, NTDC, K Electric, etc. For these 3-4 lectures you will see that I have a different kind of a banner, and here I have mentioned a research paper for which I have also pasted a picture of the first page of that report. That report was actually result of the research on the failure in New York City in I think around 10 to 15 years before, and this was in collaboration with IEEE. So I have taken most of the material for these 3-4 slides from this paper. So I thought that I must mention this paper and very clearly I should write and paste the picture that I have taken the matter from this research paper. Although I have passed through and I have an operational experience of all these kind of things during my course of duties, but as I have referred this, and I think this paper is really very informative, highly researched, and provides a great insight in the power system and power system stability, problems, effect, causes, detection, and the strategies for the system improvement for improving the transient state stability. So although I have done all those items, all those aspects in my lectures in the classroom, which I have already uploaded, I think this will help you in getting and in writing some kind of report if you are doing MS or PhD level work. So with this brief introduction, I will now move to the next slide, and you will see that the most of the things I have already covered in the classroom type of setting interactively on the whiteboard. So the first one, you will see that if you want to improve the power system stability, there is a very typical and simple method used by the utility companies, where I have been also using, and I have made settings like this, that you can have a single pole tripping of the circuit breakers. In this case, what happens, the two breakers, two contacts or two poles are intact and the power can still flow and the system remains in synchronism because the two poles are tied up from both the sides of the power system. So this helps in the stability of the power system. And then you can have a single pole reclosing whenever there is and availability of the operating mechanism independently, that each pole has its own operating mechanism and operating rod, and each pole has its own independent tripping coil or sometimes two tripping coils for each pole. So this is the prerequisite for the single pole tripping, that you must have a independent operating rod for each of the poles of the circuit breaker, and normally on 220 kV and above, almost all the breakers are singly operated kind of breakers, and it is very easy to set the distance relay or the equalizing relay for single pole tripping when the two poles remain intact. So this helps in improving the transient state stability and also the steady state stability of the system. Now, if this is one kind of method, don't think that one kind, second, three, four, five kind, they are used one by one. No, all these are implemented automatically in the power system. The settings are there, and all those things which are I'm going to mention here, or which is mentioned in the paper, are all of those measures are in the field, already in the field, and we have been applying all these kind of things in the power system to improve the system stability. So we are not talking anything about the something like a future or something which is not present in the field at this time when I am delivering this lecture. Now there is one concept of dynamic braking, that you install some artificial kind of loads on the generator and you reduce the rotor acceleration. Now here comes those lecture, you can go through my lecture where I explained very clearly the acceleration and deceleration of the generator and the increment in the rotor angle due to the rejection of the load or the addition of the load abruptly on the power system due to the tripping at various points in the power system. So artificial braking system can be applied and are applied at some generating stations to decelerate the generator so that the rotor angle does not increase and the power stable limit, that is P is equal to PM and P mechanical is equal to P electrical, is achieved as soon as possible, and thus the system returns to the stable state. Then shunt compensation, you know that is a very old kind of arrangement that you can add up, or automatically these are added up with the help of the relays, with the help of the FACT devices. You know the FACT devices, FACT, that is the flexible AC transmission system. Automatically you have the power electronics, and then you have the thyristor, and automatically the reactive power is fed into the power system. So this increases the voltages and helps in maintaining the voltage and improve the stability, and this actually helps in keeping the interconnected generators in synchronism. So this is really a very good arrangement, but again I am telling you that nothing is new. All these I have covered in those lectures which are interactively uploaded in the classroom, and everything is on the field. So if you are in the field and you are inquisitive about these things, you can always find out from the power plant or from the grid station engineer. I have worked as a grid station in substation, grid station for 40-50 years, and I have conducted many times the studies of all kind of studies, and plus I have also given the projects to the final year engineering students, at least 10 to 15 projects for different kind of system studies, including the relay coordination, etc., on ETAP, SYNCOL, and PSS. Now, another kind of method to improve transient stability is the steam turbine fast valving. So the fast valving to reduce generator output without removing unit from service. So this helps in removing the load from the generator so that this generator does not decelerate and it comes to the stable position as quickly as possible. Then you know there is generator tripping, so you can have the selective tripping, and this also I have explained in an interactive class lecture on whiteboard, that you can have the out of step tripping, that you through the transient stability. In those lectures I have mentioned that through the transient state stability you can always locate those point which at point, that at those point you can separate the system and you can achieve a kind of a islanding and some of the generators are saved, and if they are interconnected system, then all the systems do not go into the stage of the instability. So you save the machines and the power plant, and the total area breakdown does not happen. As you have seen in case of the Pakistan, many times you witness the uh, total breakdown in Pakistan. That is a result of that. Probably we have not done the transient state stability to achieve to identify those locations where the system can be separated in case the rotor angle increases from a certain limit. And I have mentioned what are the limit for the PSB powers, what are the critical angle limits for the rotor angle, etc. in different kind of lectures. At least 5, 6, 7 lectures I have uploaded in the classroom setting, where you can see interactively I have explained everything on the whiteboard. So then you can have also the high speed excitation system. I have explained in the other lectures on the whiteboard in classroom that whenever there is a large disturbance in the system, voltage goes down due to the fault, it is not possible for the system to increase the voltage immediately using the excitation system. So if you have very fast exciting system, then it will be possible to achieve the stability as soon as possible. And keep in mind one thing, that whenever you conduct the transient state stability, you always forget, or you always assume that there is no excitation control, there is no kind of inertia, there is no damping effect, there is no saliency in the poles, so etc. So you always conduct the power system study or the transient state stability in the worst case scenario. Then you can have also use this method, that controlled separation and load shedding. So these special protection are nothing but these can be the under frequency relays. If there is a frequency going down plus minus 5%, so it goes down 5%, below 5%, close to 5%, then you can always shed the load immediately, and the power system stability can be achieved, or the system can be secured immediately. So these are all these, again I repeat, are always in use in the power system. Nothing new, but in this research paper which I have mentioned here, the everything has been placed and written in a first class manner, that it is very easy to understand. So please go through that research paper, and that is the actually result of the actual happening in the disturbances in the New York USA system. So that paper is really very helpful. I would recommend that if you want to study further, or you are studying for MS, or you are studying your own system anywhere in the world, then please go through this paper. This is really a fantastic work, thanks to the team of that research paper. So I hope this will be a very beneficial kind of a lecture for you, and please subscribe our channel, share, and this will be great help to the junior engineers and the practicing engineers in the field. And don't think that I am asking for any commercial activity. This is purely free educational kind of activity which I love to do. Thank you very much.